Lots of TV shows and social media videos will try to give you the idea that Yellowstone could erupt catastrophically at almost any moment with little or no warning. And in fact, some of them will tell you they know when it's going to happen and that it's next week. Fortunately, we expect a good deal more warning than that. And in fact, we don't even believe that kind of eruption is possible anytime soon. Hold on, it's more interesting than that. How much warning would we expect exactly? What's truth and what's fiction? Let's find out. Here's what we're up against. Yellowstone supervolcano will erupt soon. Here's a psychic forecast. Yellowstone supervolcano eruption imminent. ? Rest of summer. It's vague. Oh, here's a good one. Yellowstone eruption today. Posted yesterday. Not looking so good on that prediction. Or, if you fell for that, horrible today. Live footage of Yellowstone's magma chamber eruption has scientists terrified. And then some AI-generated thing, because obviously that didn't happen. Or if you want to put it off a little bit, you can choose this one. Yellowstone eruption predicted in 30 days. Mark up your calendars. Some disagreement on the exact date being predicted here, I guess. But that's video. Let's do a little reading. Let's see what the papers have to say. Maybe we're going to find stuff like Yellowstone warning as supervolcano could be gearing up to explode. Or a new word, Vulcapocalypse. Fears Yellowstone supervolcano about to blow as new hotspot the size of 4 football pitches uncovered. It's gonna blow. Yellowstone supervolcano may erupt at any time and could wipe out western USA after researchers discover abnormality, which is an abnormal river of lava deep underneath Yellowstone supervolcano. It's not how magma works. Earthquake rocks US city miles from supervolcano as fears of overdue eruption return. This is about a magnitude 3.6 earthquake in Idaho. Or if you don't like that, supervolcano eruption panic spreads as animals spotted fleeing Yellowstone in great herds. Thing that never happened. So everybody's naturally curious about Yellowstone, right? And they've heard something about it, and that makes headlines like this about imminent eruptions pretty attention-grabbing, and that is perfect for people who are in the business of making clickbait. And the thing is, when you talk to people who actually study the Yellowstone volcanic system, they don't sound anything like this.
Yellowstone is most well known, I think, geologically for these really big caldera-forming eruptions. These are massive events, 1,000 times bigger than the Mount St. Helens 1980 eruption. The entire area can host eruptive vents and put huge amounts of ash into the atmosphere. And so much magma comes out of the ground that the ground actually collapses. It sort of falls into the void space that is evacuated by all of this magma. And the ash goes around the world. Now, the good news about these caldera-forming eruptions is they don't happen that often. Maybe 1 or 2 per million years, and it really depends on how the magmatic system is primed to have one of those. We're not really in the zone for one of those eruptions right now because we know the magma chamber is mostly solid. That doesn't mean that Yellowstone wouldn't have eruptions, though. Much more common than these caldera-forming events are lava flows. And in fact, all of this high ground behind us here, those are lava flows that erupted since the last big caldera-forming event in Yellowstone. Now, even more common, and these are the kinds of things we need to worry about on human timescales, are hydrothermal explosions. Yellowstone is really well known for all that hot water that's right at the surface, right? And occasionally, when these systems become sealed, and that happens when all of the minerals carried in the water sort of plug up the system, pressure can build from all of that boiling water, and eventually it can give an explosion. And we're looking at actually the aftermath of one of those explosions right here. Black Diamond, the steaming pool right over here, had this large explosion. It threw material up several hundred feet into the air. Over 1,500 rocks that were a foot or more across came out as part of that event. You can see them spread across the landscape here. This sort of thing happens every so often in Yellowstone. Small ones happen every year, maybe sometimes several times a year. Now, one of the challenges we face with earthquakes and with hydrothermal explosions, like the one that happened at Biscuit Basin, there really aren't many precursors. We don't know how to anticipate that one is happening. That's where we luck out with volcanic eruptions, because volcanoes give warnings before they erupt. As magma rises towards the surface, it has to push rock aside, and that causes the ground to inflate like a balloon. It will also crack the rock, creating earthquakes. It will create thermal anomalies. It will cause changes in water flow that may manifest as really broad changes in geyser eruptions and hot spring activity. Now, occasionally we hear that Yellowstone might be overdue for an eruption, and that's just not the way volcanoes work. Volcanoes don't act on schedules. They will erupt when there is enough eruptible magma in the subsurface to feed an eruption and pressure to get that magma up to the surface. And right now at Yellowstone, neither situation exists. So there's really not the right conditions for an eruption to happen.
We always think of Yellowstone as having these like three major caldera-forming eruptions and then a series of lava flows that have happened in between. So that's like the very generic baseline in which we kind of approached Yellowstone volcanology. Very simplistically, Yellowstone has explosive eruptions and effusive eruptions, right? And the effusive eruptions can be a basaltic or a rhyolitic lava flow, more often rhyolitic, often filling in the calderas. And then there's these explosive eruptions. The biggest ones are what we always talk about, the super eruptions. And so that's the Yellowstone's Lava Creek Tuff as well as the Huckleberry Ridge Tuff. But then there's kind of like intermediate explosive caldera-forming eruptions like the Mesa Falls Tuff, which was outside of the park, but still is kind of part of the major caldera cycles. And then the West Thumb of Yellowstone Lake was also a caldera, right? And so there's these smaller explosive eruptions that don't get nearly as much press, but also happen in Yellowstone. But the thing that has really changed, I think, over the last few decades is recognition that, you know, what we may have mapped as one singular event is actually many events, and that some of these are much more closely spaced in time than what we maybe originally were able to resolve based on the dating technology that we had at the time. So we've been working in the Sour Creek Dome for the last 5 years. We're finding a lot of new eruptive phases of the Lava Creek Tuff eruption, suggesting that it was not just this singular 2 phases eruption that came out, but actually lots of smaller magma bodies that were erupted in geologically instantaneous time. But there is evidence for one of them actually having cooled completely after it was erupted and then broken apart in a subsequent eruption that suggests like, okay, maybe you had this big eruption, maybe nothing happened for, you know, decades, and then you had another eruption. And so again, that really changes how we view these eruptions proceeding, but that's all essentially the same eruption. That's all the Lava Creek Tuff eruption. So I think that there's so much nuance into how these eruptions come out, the pauses that they have within them, how they build, what triggers them to start and stop, that, you know, a lot of times just saying that it just like builds up, pressurizes, goes boom, stops, and then refills is like so simplistic of what is actually happening in the system that it's not super useful to even use that framework to think about these things.
One of the things we do to study past eruptions is we look at the individual crystals that are erupted as part of lavas. And when we look at those crystals that are in the lava under the microscope, we can see that they have concentric zones or rings. And these rings are like similar to how trees have rings. And similarly, these rings or zones and crystals record information about the climate in the magma chamber when the crystal was growing, or things about the temperature and the pressure and the chemistry and the volatile content. The rings don't grow every year the same way tree rings grow, but we do have the ability to calculate the time back from the eruption when the individual crystal zone or ring was growing. And so it allows us to document when particular things were happening in the magma chamber relative to the time of the eruption. So we've looked at both lava flow eruptions, what we call effusive eruptions, where the volcano sort of burped out a really viscous, toothpastey-like lava flow that didn't go very far. And we've studied the big explosive eruptions that spread ash all over the United States. And by studying the individual crystal histories, we've learned that some of the events that have led up to these eruptions are things like injection of magma. So we have a magma storage region below the volcano that's probably very crystalline. It's cooled off a lot over time and formed a lot of crystals. And then a new hotter batch of magma comes from deeper in the Earth's crust into that shallow storage region and heats up the magma storage region again. So analogy I like to use for this is like we're drinking an icy or a slushy, where when you first get the drink, it's mostly ice with a little bit of liquid, but then you melt some of the ice and it's easier to suck it through a straw. When we look at the largest explosive eruption that Yellowstone had in the recent past, that one about 640,000 years ago, we saw that there was a magma injection event that happened in the years leading up to the eruption. And so over the timescale of years, it's maybe faster than some geologists would expect, but it's certainly a long enough time in the span of a human life that we could see the precursor signals like earthquakes and changes in the gases coming out of the magmatic system that would tell us that there was a magma injection event happening at depth. So you have the condition that the magma chamber is in to begin with, and maybe it's closer to the tipping point of being eruptible, or maybe it's further away. So then it matters how big the injection of magma is, how much it is, how hot it is will matter then too. But so we're way below. There's no way that we can erupt that. That's a locked mass, right? It's like I can't drink my slushy. It's too much ice. There's no liquid. I can't draw it through a straw. So some big events would have to happen to heat up the magma chamber and produce, a higher liquid to crystal ratio to get it to be eruptible. There's a big difference between somewhere in the ballpark of 50% liquid, versus, 6 to 9 or something like that. I mean, right now, I'm not worried about an eruption. There aren't any indicating signs. But if we started to see a lot of earthquakes where, the seismologists who study the records can tell that this is magma movement at depth and not the hydrothermal system, that might be an indication that we have a potential to warm up the magma chamber to be eruptible. Another key indicator is the type of gas that's emitted from the volcano. And by looking at the ratio of things like the sulfur and the carbon dioxide, those ratios change, we've found, leading up to an eruption. And finally, we monitor the surface of the volcano, so how high the ground level is. And so if we saw a period of inflation coupled with any of those other signals, that would also be a good indicator that there was, perhaps more magma being injected below the surface of the volcano.
This is not just about noticing anomalies that would trip alarms. It's about detecting trends over time. So one little earthquake is not really noteworthy. There's over 1,000 earthquakes here every year, but a series of earthquakes that are migrating in some direction could show us where pressure is also moving around.
Yeah, I mean, all I really ever tell people is that there is very unlikely that there's going to be an eruption in their lifetime, that they're not going to die from some kind of super eruption that is happening, that it's a very well-monitored system, and that we have an understanding of what could happen.
Occasionally, you'll also hear these statistics. There's a 1 in 700,000 chance or something of an eruption this year. Well, I suppose that might be true from a purely statistical standpoint, but the conditions aren't there right now. So it would be a bit like saying, there is a chance that you're going to be struck by lightning. But what are the odds that we're going to be struck by lightning right now? Pretty much zero, right? Because the conditions aren't there to generate lightning. That's the sort of situation we're in Yellowstone now, a nice quiet period where we know the magma chamber's not really brewing for an eruption. If it ever did start to brew, we'd have ample warning.
Yellowstone, like other volcanoes, does present real dangers, and it's good that we're aware of that, but it's also important that we prepare for the right things. Sorry if that's not as exciting as a disaster movie, but you don't really want to live through a disaster movie anyway. There are a lot of people working hard to study and monitor Yellowstone all the time. If you want to learn more about that, visit the Yellowstone Volcano Observatory website. It's guaranteed clickbait free.